Hello everyone, good afternoon. Dear authors and invited guests, welcome technical session 9F. Myself Deepika Jain and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the International Conference on Smart Trends in Computing and Communications SMARTCOM 2025, Pune, India. The ninth edition of this conference has been organized in a hybrid mode. The physical event was held in Pune and the virtual event was held through Zoom yesterday and today. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presenters, and each presenter would be getting 8 minutes for their presentation and 2 minutes for question and answers. On 7 minutes, I'll be raising a gentle reminder. I also request all the participants to stay connected with us till the end of the session. If you have any query, you can just write to me in the chat box. Just before we start the session, I would like to introduce to our session chair, Dr. Aneri Kilol Pandya. I welcome you, ma'am.
Thank you.
Dr. Aneri Kilol Pandya is an assistant professor at Charusat University, Gujarat, India. She has completed a BE in 2008 and ME in 2010 from Maharaja Sayajrao University of Baroda and earned her PhD from Charusat University in 2022. With over 13 years of experience in academics, Ms. Pandya has contributed significantly to research, publishing 20 papers in journals and conferences. Thank you, ma'am. I welcome you. So
Thank
we
you. And good afternoon, everyone. And it's been pleasure to have a session chat at SmartCon 2025. And I'm looking forward for some amazing presentation, which covers the topic like video gaming, smart surveillance, robotics, and many more. So without wasting much more time, let us start and let us have a good research and innovative work that we are looking forward for. Thank
yes,
you.
ma'am. Sure, ma'am. Sure. Thank you. Okay, so we have our next first presenter with us, Hendrik Pretorius, who would be presenting a paper on a classification of persuasive features in video games, a structured literature review. Hendrik, sir, you are on mute. Please unmute yourself. Yes, sir, I can hear you now. You can start sharing your screen, please.
Thank you very much. Good morning, everyone. In South Africa, it's still morning, so I'm just going to share my presentation.
Yes, sir. Good morning, and you can just start sharing your screen.
Can you see my screen?
Not yet.
Okay, let me try again.
Just
Okay, so
yeah, I can see your screen now.
okay, so thank you for that. Okay, so I'm from South Africa. I was actually the supervisor of this student that is called Vumisa. So she couldn't make it today, so I will be presenting the paper for her. So here and there, obviously, she's the one that actually got all the knowledge. So I will try my best to present it as I can remember it because I actually have a lot of students. Okay, so this is about persuasive features in gaming. Just to give you an overview of the problem statement, you can see there's a lot of gamers that's quite involved in playing video games. And we want to actually see what is the motivation why gamers actually stay so comprehensive behind the game, so they can stay there for quite a lot of time. So we actually did a bit of an investigation to see why they actually want to stay in or play so much games, and also to see what sort of behavior changes actually these games actually cause to gamers who actually play videos. So we actually did some analysis of the persuasive features, how it actually changes behavior of all of these games, of all of these people that's playing games. So, and that's why we try to understand. We try to get the motivations and also try to understand the change behavior behind gamers that actually play video games. And for that, we actually developed a systematic classification of all of these features that we are talking about. Okay, so the objective of this research paper is to analyze the persuasive features in video games and to also understand the user's motivations for continued engagement in these games. So, and then actually to develop a classification of these features. And this is to address the following research question: what persuasive features are utilized within video games and how can they be classified? Okay, so in order to do this, we did a systematic literature review. We actually used data sources like ProQuest, Science Direct, Emerald. You should all be familiar with these databases: IEEE, Explore, Digital Library, and EBSCOhost. Okay, and in those databases, I just actually have one example of the search terms. They differ slightly from database to database, but we use this search term, as you can see there, persuasive features or persuasive technology or persuasive gaming or gaming motivation and so on in these databases, and we actually got the literature back. Then basically we applied some filters to actually get the correct literature. Filters like it should be recent research, last 5 years, it should be in English, and so on. So, and it also should be related to what we are actually looking for. So after that, we actually remained with about 29 papers that we actually investigated to get these persuasive features. Okay, we also use some theories in persuasive gaming features that actually came through on these papers. And there is a couple of those theories. I'm not going to go into detail about these theories, but I'll just maybe mention the first one there. And these actually explain some of the persuasive game features that's available. So if you actually read the full paper, you will actually see a lot of these persuasive features that's mentioned while you are using these theories. So for example, if I just look at the first one there, there's a Bartlett's theory, and they actually classify players into, you can see those four things there. The one is killers. That's why they play games. They want to be killers. It's not a nice thing, but okay. Achievers there, socializers. You can see 80% of the people play games or get so much engaged into gaming because of the social features. They can chat with other people, they can play with other people, and so on. And about 10% there you can see is explorers. They like to see new worlds, they like to discover new things, and so on. And there's all of these theories that you can actually use to actually identify some of these features. Maybe another one that I will actually explain is number 5 there, self-determination theory. It basically comes down that in this gaming environment, you are allowed to be yourself. You have the free will to be what you want to be in this gaming environment. So it's about autonomy, competence, relatedness. So you cannot always do that in the real world. So this is almost like a environment in which you can really be yourself, and you can show that you are competent, for example, achieving certain levels, and you can relate to it. So we actually use these 5 theories. You can see the flow theory, social cognitive theory, users and gratification theory to identify these features. Okay, then when we identified these features, we actually tried to classify them into different areas. So you can see why some of the gamers are so engaged in video gaming is because of the social features. For example, social interaction. You can play with other people. You can also read reviews or post another review. So it's just a way, and you can see most of the people actually like the social features in gaming. I know, for example, my own son sit and play with people across the world, and he really spend a lot of time behind the computer. So it's all about the social side as well. Then we did talk about personalization features. You are allowed to be the way you want to be in a game. So the way you create your avatar, the way that you can actually see yourself, it's features that you can actually use to create the person that you would like to be. Autonomy. Then there's also features like that's more involved with money, that we call that monetization features, and that's actually where people are want to stay in the game, so they buy these small little things like, for example, if it's a fighting game or so on, or a social game, they will buy new furniture and so on, and they try to keep up with the rest of the environment. So they have these in-game transactions that they actually do to actually improve themselves and to be part of this environment, and that actually keeps them quite busy. So you can buy new guns, you can buy new houses, you can buy new tools, you can buy furniture, all of that. For a lot of people, that is some sort of an attraction. Uh, you can actually play the game. In the old days, they actually use subscriptions. You have to pay per month to be part of this game, but this microtransactions, which is basically allowed you to play the whole game, but you can do these transactions now, and it's becoming addictive. It keeps people in the game. They want to have
Dear
more.
presenter, you have 2 minutes left.
Okay, so there's also the immersion features like the storyline. If you're in a virtual world, basically there's a storyline, something that's maybe not real that you or everyday. It's things like that, the aesthetics, the audio, the video. It's things like that that can keep people in the game. And there's also the behavioral feature, awards, points, scores, feedback that you can get that's maybe good and so on. The challenges that you have to complete, the progression that you are competitive, you want to actually have in this environment. So that's all the persuasive features that keep people actually playing games. We've classified it into those 5 categories. Okay, so the conclusion is basically we analyze 30 articles and we use these theories to identify these features. So, and the study emphasizes how these persuasive elements influence player behavior, attitude, well-being, and offering a guide for game designers and researchers in creating persuasive features. So you can actually use those things to actually create new games and sell that, and it will actually engage players and video gamers who actually play video games. The future research you can actually look at. Okay, so that it was me. I'm from the University of Pretoria, Department of Informatics. There's my email address if there's any questions. Thank you. So I'm going to stop sharing, and then if there's any questions, I would like to hear that.
Thank you, Hendrik. Thank you for the presentation. Any questions, ma'am?
Yes. Hendrik, I want to ask that how you can your findings of the review will be applied on the design of any educational game.
Yeah, I think obviously some of those features you can obviously do in education. I think we also have research teams that's actually doing that. We have a lot of people that actually work in that focus area. Things like rewards, for example, by giving people certain rewards if they do things correctly, that actually helps. Things like motivations, giving feedback that is motivational and that sort of thing. All of those things can actually help you to actually, in an educational environment, to actually play educational games to learn something from that. It's also, I think, if I can think just quickly on my feet, it's also, I think, how creatively you can actually apply um, uh, the knowledge when you actually design educational games. I think that also might play a role. You must make it really interactive. You must try to get things like audio, immersive features. All of those things would actually play a big role to get the people to keep on trying to get better and better and better. Yes.
Okay, okay, okay. Okay, thank you.
Thank you, Hendrik. Thank you, ma'am. Thank you.
Thank you.
Okay, so any
Okay.
other questions?
If the participants have any questions, they can, convert it in the chat, open chat forum. Yeah. Thank you, sir. Thank you. Of this paper here.
Yes, I'm here.
Yeah. Are
I'm
you ready with
author.
your presentation, sir?
Yes. Okay.
Okay. So you.
Okay. Give me a minute.
Yes, please.
Okay.
I request all the presenters to be present, to be ready with their presentation. If the other participants do not turn on, we can just take your turn.
Oh, you can see my screen. Hello.
Yes, I
Can you
can
see
see your
my?
screen. Yes, yes.
Okay. Let
You
me
can
start.
start. Yes,
Okay.
sure.
Hello everybody. My name Thế Tuấn Thần. I'm from Vietnam, and now today I will present an approach for real-time object checking integration with adaptive occlusion handling on the robot. And my presentation include 4 parts: introduction, robot show visual checking, result, and conclusions. In introduction, so first and introduce elderly support have analysis in the action in flight, and it offers solution to global aging pollution issue, and it reduce the burdens on healthy and healthcare and social welfare system. Basically benefit their family memory. And with my research is across occlusion. Occlusion is object is partially or completely obscured by another object. It make the symbolic score of safely reduce reliability, increase noise in the realistic position. And I review on other research, and I see it's two challenge: the occlusions challenge and limited computation resource, because deep learning based model provide robust solution to most of perception problem involve person following. Uh, However, is iterative advance in power checking around into the embedded system. Like robots is a challenge due to computational capacity and power consumption. And so I propose a combination of KCF and KF with average picture contraction entry ABCE to address occlusion. So in this spec, I will introduce about the ABCE index and the combination KF and KCF and KF. Firstly, we use ABC to deal with occlusion and update model, because ABC has some clear benefits such as high sensitive to change, reliable and adaptive to real-time processing. And So ABC is the essential for assessing the adaptive occlusion state. The classifier evaluate the sample image plug and generate the response map. This response map reflects the degree of correspondence of each pixel within the image plug and to the model of the target check. And the ABC index not only provide information about target local, but also help identify the occlusion or noise condition affect the check target. You can see the equation. F max is maximum response value, F min maximum, and F WF as the response value at the position. So this is sample when I IBC values in the sequence video in OTP 100. And you can see at the beginning of checking in the first frame, the IBC value is, sorry. Values inherits be 130, 34 in frame 46 is target is skews occlusion happened, and ABC value is response map prop is to close value is 199.26. Subsequently, the Roboso algorithm adjusts the model learning rate to redetect and the target object from frame 64 and restoring a checking state and making the response map more reliable. And the Roboso visual checking algorithm. Firstly, we combination of KCF and KF. Next is the ABC employed to determine the likelihood of occlusion or rechecking of target. It is two cases. One is if the object is occludes, the system stop update the model to prevent incorrect update. And if the target is subsequently rechecking the field, and the system will update the model with increased learning rate compared to initial value. So the combine now, I will go into more detail of about the combination of K-shape algorithm and Kalman filter. The initial position of the object is initial using initial coordinates. Then algorithm begin the checking loop for object rod on frame in the video. The Kalman filter is predict the current position of object using the state of update equation based on previous state information. Subsequently, SOG feature of object and related person adjective for checking for the following frame. So about the experiment, we use two datasets, the OTP 100 and last shot. We experiment on two hardware, personal computer and with Intel i7 and embedded computer with Jetson Nano, and we use OTP 100 and last shot. Now, parallel 100 we compare to the not using non-deep learning, and we use compare in three parameter is OP, it is overlap resistance, DP distance resistance, and FPS frame per second. And you can see it we use video sequence and compare with a lot of seven checker where it is not deep learning checker, non-linear checker, and it's in my checker on personal computer, and it is my checker, and you can see this is for average, and you can see my checker it has a resistance is high, and FPS is second rank, and on yesterday the FPS is achieved to real time processing.
Dear presenter, you have 2 minutes left.
Okay. Now it is so I compare to 6 top set checker, and it is non-deep checking. Yes, and we evaluate on occlusion. I see you can see the out checker and auto checker. This is a deep checker, and you can see my checker had resistance 0.602 and high risk in on checker. Next is last shot. We use 2 attribute of last shot, a full occlusion and particle occlusion, and you can see my checker is full occlusion is high, and particle occlusion is third rank. Yes. On qualitative analysis, you can see rest is my checker, and other checker is KCF, DXT, MIL, KCF, and you can see two case is occlusion and motion blur, and you can see rest on way checking the target, and this yellow loss, green class, and MIL class. Yes. So conclusion, my research comparison of KCF checker with KF phase prediction and using ABC index to address occlusions. And my processing speed on CPU, my checker run on CPU. On CPU on embedded device reach to 30 FPS for OTP 100 and 13 FPS for last shots. So, thanks for your attention. I'm delighted to receive questions and feedback from everyone. Thank you.
Thank you. Thank you for your presentation. Any question, ma'am?
Okay, there is one question. How does your approach compare to the existing any object tracking method in terms of reliability?
Existing. Sorry, you can see.
How does your approach? I'm repeating the question. How does your approach compare to the existing object tracking method in terms of the reliability? Or how you are representing reliability in your object tracking system? What is the reliability?
I compared approach to, so the first step on my research, I just compare the checker on the ORM on the data set, So I not compare on the forward system when applied the checker on hardware. So
Okay. Over to you, Deepika.
Yes, ma'am. Thank you, sir. Thank you for the presentation.
thank you so much.
Thank you. Okay, so we have our next presenter with us, SP Vibhuti, who would be presenting a paper on advancing energy efficiency in 6G networks through empirical analysis of intelligent configuration models. Ma'am?
Hello.
Yes, yes, I can hear you. Can you please share your screen?
Yes.
Yes, please.
Is the PPT visible?
Yes, yes.
Okay.
You can start, please.
Yeah. Good afternoon, all of you. I'm Mrs. Shubhangvi Bhute and presenting here. So this is the law of literature survey methodology results comparative.
Ma'am, you're not audible. Hello? Please unmute yourself. Ma'am, please unmute yourself. I can't hear you. Please unmute yourself, ma'am. Okay, maybe. Please fix your issue and we can take you next, ma'am. Okay, we can go with our next presentation. Pulipaka Rishita, are you here?
Yes, ma'am, I'm here.
You're ready with your presentation, right?
Yes, ma'am.
Yeah, you can start sharing your screen, please.
Yes, ma'am.
I can see your screen.
Is it visible, ma'am?
Yes, yes.
Shall I go ahead and start?
Yes, please.
Okay. So, good afternoon, everyone. So today I'll be presenting our work on the comparative evaluation of Llama 2 in medical application. So this research explores how we can leverage large language models to improve healthcare support, particularly in mental health applications. Coming to the abstract, so what is our project? What is our paper trying to tell us? Or what did we implement in our paper? So our study evaluates the integration of Llama 2 into a healthcare platform focusing on both medical and mental health support. So we've equipped the model with retrieval augmented generation, that is RAG, to enhance its ability to provide accurate and empathetic responses. So a key aspect of our research was testing Llama 2 across 4 different scenarios, comparing its performance with and without fine-tuning and custom prompts. So coming to the problem statement, so what we are trying to solve here is the core challenge we are addressing is the fragmented nature of existing digital health platforms. So the current solutions typically exist in either medical or mental health support, but rarely both. So our goal is to create a unified platform that can handle both domains effectively. Additionally, we aim to evaluate how Llama 2 performs when interpreting diverse medical and mental health prompts. So let's talk about what work has been done in this field before. So one of this is the first work which is being done, which is a MedBot, and which was developed using a multilingual conversational bot for rural healthcare needs, and which is being used, as you can see from the architecture right here. It's been used with GCP, and it's been deployed on the GCP cloud. And let's look at the next paper. And another significant contribution was in AI-based medical chatbot model, which can predict infectious diseases. And yeah, sorry. So yeah, this paper also talks about 3 different methods what they took here, and they were trying to tell us the accuracy and time complexity. So from these 2 papers, so we can understand that these studies demonstrate the potential of AI in healthcare, but also highlighted the need for more comprehensive solutions. So the proposed solution, what we are trying to give here, is that our solution addresses this limitation through a systematic approach. We've implemented a 5-step process, starting with document loading, splitting content into manageable chunks, then converting this into embeddings, performing similarity search, and finally generating answers using Llama 2 with retrieval QA chain. So this approach ensures both accuracy and context awareness in responses. Coming to a methodology, the flow of our methodology. So right here, this shows several key components. So first is the database. We're gonna give our data sets, and then it's gonna go to the line chain where it's gonna try to remove any unnecessary things, and it tries to split all of the, let's say I'm talking about a CSV sheet, it tries to split it into proper substructures so that it is easy for it to process it later. So after doing that, it tries to create vector embeddings, which is done in sentence transformers. So what is the point of vector embeddings here is that it tries to give a value to each split what it does, so that based on this value, when you try to give a prompt, it's gonna it's gonna change your prompt also into a vector embedding, and it will try to match and give us a proper result. So here, when we after using the sentence transformer, we are trying to generate the sentence level semantics in our vector DB. Here we are using FIS. So the main thing what I forgot to tell when I was talking about the previous thing was, so FIS is something which can do similarity search. It works really well on similarity search. So this vector DB stores embeddings, and the Llama 2, our large language model, generates response based on user prompts and retrieve context. As I've mentioned, first, the user gives the input, that's the prompt. And this goes to the vector embedding, and the same after, and then when you give the prompt, it tries to match to the most relevant question what you're trying to ask, and then it tries to, and it tells the large language model, okay, this is what it is. And the large language model, using RAG as its inbuilt architecture, it'll try to enhance the answer more and then gives the user its required output. Now, coming to our data set. So we utilize a diverse data set, including the Gale Encyclopedia of Medicine, Food and Allergen Information, and specialized mental health counseling data. This comprehensive collection ensures our model can handle a wide range of medical and mental health queries effectively. So just to make one point clear is that this is an experimental setup what we are trying to do. So in order to get like more better results, we have to use a better data set, as this paper talks about how Llama 2 how large language models can have a very good effect on in the domain of healthcare. So yeah, and coming to our evaluation metrics. So for evaluation, we employed pairwise evaluators, which was present in LangChain, for comparing responses from different configurations of our systems. So this allowed us to directly assess which approaches were most effective in terms of accuracy, empathy, and relevance. So coming to our results. So our results show significant improvements when combining fine-tuning with custom prompts. As you can see in
Presenter,
the,
you have 2 minutes left.
okay. As you can see in this comparison, responses with both optimization demonstrated better structure, empathy, and practical guidance compared to baseline approaches. As you can see here, this is with fine-tuning. This is without fine-tuning. This is what the answer what the model gave. And bottom is without the custom prompt, which we had given for it to make it more empathetic or not. And this is without the custom prompt, without fine tuning. So analysis. So our results show, as I've told, our results show significant improvements when combining fine tuning with custom prompt. And there is a lot of things that can be done further. And coming to our conclusion. So in our conclusion, our research demonstrated that Llama 2, when properly configured with RAG and fine-tuning, can effectively serve as a comprehensive healthcare support system. So coming to the future work. So the future work will focus on multimodal inputs and closer collaboration with healthcare professionals. And also, the main important point we need to understand here is that we can't entirely depend on this assistant to help people, but it can assist healthcare professionals in hospitals and other facilities where it can give us a better understanding about what the person is going through. Thank you, and I'm happy to take any questions about our methodology or findings.
Thank you.
Okay. My voice is audible?
Yes, ma'am.
Okay.
Yes,
So I have one question, and that is that how did you benchmark Llama performance against the other AI models in the same field? That is, you are focusing on the medical field.
Can you come again, ma'am? I didn't get you.
Okay. How did you benchmark Llama performance against the other AI models?
So, ma'am, in this research, we were only trying to focus on our Llama 2 model, which was the latest model when we were doing our paper. So that was the open source model, which was available for us. And also that model consists of 7 billion tokens, and if we have to take more tokens, we need a better GPU for that, which we didn't have. So we wanted to do a research based on how well this open source model can actually be helpful in the case of mental health, especially in medical domain. So we didn't compare with other models. We were just trying to go in depth of the Llama 2 open source model, which we were trying to do it. Did I answer your question, ma'am, or do you want me to answer it
No,
in a better way?
it's okay. I get the answer. And were there any challenges in training the Llama for this application you are facing whenever you are going through the process?
Yeah. So when we were trying to train the model, uh, initially we were not able to the model was not able to properly give the answers. I mean, it was going into a state of hallucination at a point of time. So we had to like change the custom the architecture the custom changes in that. So we need to change how many times the words are getting repeated, and how many times it can look into the data sets what's been given. So that part we were finding a bit of challenge. And the other challenge was we were getting a prompt, but we were finding it hard to compare, is this what is right given I mean compared to the present. How do we need how does a human perceive information the way we are doing? So that was a hard part, and we had to dig into that, and that is how we ended up using pairwise evaluators from LangChain.
Okay, thank you.
Yeah, thank you, ma'am.
Thank you. Thank you, ma'am. We have our next presenter with us, SV Vibhuti. Are you ready with the presentation now, ma'am?
Yes, ma'am.
Please share your screen.
Everyone, I'm Mrs. Shubhangi
yes.
Vibhute, presenting the paper Advancing Energy Efficiency in 6G Networks through Empirical Analysis of Intelligent Configuration Models. So this is the flow: introduction, literature survey, research findings, methodology used, then the results, comparative result analysis, findings from comparative result analysis, and then the conclusion. So this is the introduction. There is a necessity of innovative strategies to enhance the efficiency, energy efficiency for 6G networks without compromising the performance. So our work systematically reviews and analyzes variety of models, including sleep scheduling, to augment the energy efficiency of 6G networks. So this is the literature survey. In this, we have reviewed around 50 papers, and here is the research findings. So this research in the field of 6G network covers wide range of topics like application of machine learning, addressing the challenges in massive ultra reliable low latency connectivity, resource efficiency in IoT networks, then IoT security and reliability, cooperative autonomous driving for CAVs in network computing, and energy harvesting with privacy preservation. So these studies contribute to the development of 6G networks and their potential applications in various domains. So this is the methodology used while conducting this research. First, the MIMO system, it is simulated in a network simulator NS2. Then the sleep scheduling algorithm is implemented for power optimization. And then the performance, it is compared with and without a sleep scheduling algorithm. So these performance parameters, these are the energy consumption and delay. So this is the sleep scheduling algorithm, which consists of the initialization process, node selection. So under this sleep scheduling, the energy monitoring is done. The active nodes, the nodes are classified into active nodes and sleep nodes, depending on the energy level. If it is less than mean energy, then it is classified as sleep node. And thus, the energy comparisons are done. If the energy is less than mean energy, then the node is placed as a sleep node. And this process will be repeating. So these are the results on network simulator. So this is the simulation for one communication for 20 source nodes and 30 destination nodes. Here, the number of communications are increased to 4 for same source nodes and destination nodes. So here, the results are compared for energy and delay with and without sleep scheduling. So here we can see that energy with sleep scheduling, it is lesser than the energy without sleep scheduling. Also, we can compare the delay with sleep scheduling. It is less than the delay without sleep scheduling. So here, this is the comparison plot for energy consumption with and without sleep scheduling. So here also we can observe the performance improvement. This is for average delay with and without sleep scheduling. So the comparative result analysis is done for these 50 papers where these performance parameters, delay complexity, cost, energy efficiency, and scalability, these are compared. So these are the findings from this comparative result analysis. So this analysis revealed that methods like sleep scheduling and spectrum sharing, these are having better performance, while deep learning and swarm optimization and also millimeter wave technology show promise in terms of high energy efficiency and scalability. But these are beset by high complexity and the cost. Also, the methods that exhibit low complexity, such as green anaconda optimization, base energy aware clustering protocol, these may not necessarily offer the best in energy efficiency and scalability. So this intricate the balance between various performance metrics, which method for practical applications. So this is the conclusion. So our work revealed that the sleep scheduling shows better performance in terms of energy consumption and delay. So by this experimentation, the energy consumption with sleep scheduling, it is decreased by 81.34%, while delay is decreased by 11.44%. So for this, the future scope will be, we can integrate this with deep learning and we can consider the environmental conditions while doing this research. So these are the references. Thank you.
Thank you, Shubhangi, for the presentation. Any questions, ma'am?
What is you are focusing on MIMO? So can you give the advantages or what are the main features of the MIMO, or you can explain the spatial sharing? What is spatial sharing in MIMO?
Pardon, ma'am?
Main advantage or
Hello?
what are the main features of MIMO antenna?
Spatial features.
Yes.
So the MIMO is the multiple input, multiple output antennas. So due to the spatial diversity, the efficiency of transmission is more in case of MIMO.
And how the multiplexing and decoding will be done in that? You have any idea regarding that?
Yes, for multiplexing, OFDM is used.
Okay. Okay.
Thank you. Thank you, ma'am. Thank you, Shubhangi.
Thank you very much.
We move to our next presentation, which will be given by Lakshay Khanna, who would be presenting a paper on electric vehicle sales prediction using machine learning and statistical models. Lakshay, are you ready?
Yes, ma'am, I'm ready.
Please share your screen.
Yes, ma'am. Ma'am, is the PPT visible?
Yes.
So, good afternoon, everyone. So, we are today discussing a topic on my research paper, electric vehicle sales prediction using machine learning and statistical models. So, we have enrolled various statistical models and we have performed a comparative study on it and applied it on our particular data set. So this is our table of contents that we are going through. Introduction about why this problem is needed, literature review, data set that we have used, models applied, discussed, and the results of that model, conclusion and references. So let us move towards the introduction section. Since we are seeing it with our practical insights that EV sales are increasing day by day and everyone is moving towards the use of efficient fueling mechanism instead of petroleum and diesels. We are avoiding it. So the growth of EV market is getting increased day by day, and this is the data of around 2021 that up till now 9% of the global market is occupied with the EV segment. Even the high brands like BMW and all are creating EVs, releasing their EVs, including Teslas and all, to make the betterment of the society. And also this sales prediction can be utilized in not only in EV segment, but in other segment also by the manufacturers, policymakers, and the fuel providers. So this is our main introduction that we are seeing. So we have performed the literature review of around 15 papers. The 10 of them are in the list, in which there are a lot of papers, but I have included 10 papers. So the models used are similarly, the accuracy of these models and these papers lies between 80 to 95% in all the papers. These papers usually have used artificial networks. Some have used multiple linear regression, support vector machines, improved GM1 model, decision tree random forest, and many more classification. One more is CARDS algorithm. So these are the kinds of long-shot LSTM deep learning model. These are the models that they have implemented in their papers and work. But this is not for just the revenue and all, but they have done it for the prediction purposes. So we have taken some of these models and some new models that are coming into the generation, and for our comparative analysis. So let us study about where the data set was taken from, how is our data set, what pre-processing we have applied. So data set is taken from the Kaggle, because since we have searched from the authentic data sets, we are unable to find the sales data regarding all the companies. So we have taken it from Kaggle. The time period is from the January 2012 to December 2019, and we have predicted it in 2021. And the features are basically the table names, we can say attributes, which have manufacturer, model, and monthly sales data. Let me show you the image of the data set. The first image, for example, make is the manufacturer name, model is the type of model that company, like for example, Chevrolet may have two or more than one particular model for an EV segment, and the monthly data of sales from January 12 to December 19. 12 stands for 2012 and 2019. Till that is the data. So this is how our data is. So of structure, as I have discussed, there are each company and the model of that particular segment and the sales data. So observations, we can see we have encountered that there are various duplicate values and errors. For example, first error is shown in this table itself. We have Jan V12 written. So there is a date formatting error that is happened over there. So we have altered that error. Duplicate values are being replaced, and spelling errors, for example, a month name is written instead of Jan V instead. Corrected inconsistent and formatted date time entries for analysis, and missing values for the sales are replaced by zeros. So to ensure data integrity. So this is how our pre-process. This graph is the initial sales curve from 2012 to 2019, showing the effective progress over the time. So this graph reflects as that overall sales are increasing year on year, monthly, and the growth is progressive. So now let us discuss what models that we applied. So we have applied total 5 models. One or two of them are statistical models that are Holt-Winters method and ARIMA. And the question arises, why not SARIMA? Because at first we are just thinking about not just about the seasonal trends, but after that we have also incorporated the seasonal trends. So at that time we haven't included the SARIMA model. So these models are statistical models, 2 models. So they are usually used for short to medium time forecasting, handles exponential shortening on trends, and stable used for linear modeling linear relationship between the case. And the third one is Profit. Profit is basically a model given by the Facebook for time series, decomposable time series. Handling these model is generally used for handling strong seasonal and trend patterns, which can include holiday and all. Holiday like strategic seasonal trends, monthly trends. Okay, so this is a good model. LSTM is a deep learning model with layered architecture, random forest, and symbol learning model. These 5 models we have applied. Let us see that each one of the model in detail, how the results have been published. So let us see the Holt-Winters model. So as you can see in this Holt-Winters model, we have the graph of car sales forecast. The red dots represent the forecasted value, and blue line represent the actual historic sales value. So this is how the time versus number of cars sold graph has been shown. As you can see, there are 2 equations written on the last 2 on the bottom right corner. So these equations are first equation and forecasting equation. This equation predicts future values by incorporating the smooth level trend and seasonal effect. So these kind of stuff is due. And the second equation, overall smoothing. So this is an equation which is used in forecasting equation for calculating the overall smoothing of the, or we can say provides the overall smoothing of the curve. So this is why it is used. This is Holt-Winters. And then also we have applied ARIMA. As you can see, these graphs are quite similar in look. But as you can see, at the top right corner of the graph at 1.75, there is a steep, edgy like stuff. So these models are quite similar, but there is a slight difference between them. So this is ARIMA model. Now let's see about profit, how profit works. So profit, there are 4 graphs in profit. So first profit graphs, what it represents. So this graph shows the underlying trend in the data over time, ignoring seasonal vibrations. The first graph ignores the seasonal vibrations and noise. So
Dear presenter,
interpretation.
you have 2 minutes left.
Yeah, and the second graph in this is representing the holidays. For example, in a year particular, there are some holidays, and due to that holidays, there is a certain decline of sales. And the third graph is including the monthly sales. The monthly sales there can be a drop in certain months or in a particular time, and the fourth graph is specifying the yearly pattern. So there can be a drop due to a seasonal drift. For example, back to school season, Black Friday sale season may have a certain increase in it. Then we have applied LSTM model. So blue line depicts the original data and orange line depicts the predictive data. And this is our LSTM layer structure, as you can see. Then this is our random forest model. The blue line depicts the actual and green lines depict the random forest prediction. So all these we have consolidated all the results, and these are the tables where we have calculated RMSE, MAP, and R-square value. For Ariman Holt Pointer, since it is not a time series, these are not for time series variation, the MAP is none. So on conclusion, when we talk about this, when we compare all the values and all, profit is the best model for, we can see, for the prediction. The next best model is, we can say, LSTM, and the worst model that is still being avoided because of their terrible R-square and all is Holt Pointers. So this is our conclusion on the study. These are the references. Thank you. Sorry for being too much.
Thank you. Any questions, ma'am?
Were there any challenges in balancing the statistical and machine learning approaches?
Yes, ma'am. Could you repeat the question?
Were there any challenges come across in the balancing the statistical and the machine learning approaches?
Yes, ma'am. For example, the formatting that we are having, the statistical models usually, for example, we have taken Arima and Sarima. When we are performing we can say, let us take an example of LSTM model. When we combine more than one data set, there is a interpolation we have to apply. So there is we can say, when we combine two data set and also interpolation, we have to tackle that data for a particular timestamp. So we have to do it. But in case of statistical models, when we are having statistical models, since we haven't applied Sarima, we cannot incorporate seasonal changes into it. So that can be a challenge while we are dealing with it.
Thank you. Deepika, over to you.
Yes, ma'am. Thank you. Thank you, Lakshay. Thank you. So we have Saloni with us, who would be presenting a paper on a decentralized cloud-based CCTV surveillance system using AWS S3 and blockchain for secure login.
Yes, ma'am. Hello, am I
Yes,
audible?
yes, you're audible. Please share your screen.
Sure, ma'am. Just a second. Is that visible now?
Yes, yes.
Okay, so hello, I'm Saloni Mahaduri, and I will be presenting this paper on behalf of Sahil Thakur. So our project paper title is Decentralized Cloud-Based CCTV Surveillance System using AWS S3 and blockchain for secure login. So this is the abstract. An introduction. As we all know, that CCTV cameras are in today's time are very valuable tools that provide security to individuals as well as other organizations and educational systems also. However, when the quantity of video data comes into the picture, it increases daily. Since we record the videos on daily basis for 24 hours, so it becomes very heavy to store at any store the videos on any platform. So we have come up with a solution to store the CCTV footages in the form of frames on Amazon S3 bucket. So using S3 bucket is a kind of uh, easy, and it also provides a large amount of storage. So our project idea was to use OpenCV library in order to collect video frames, 5 frames per second, and then store it on the AWS S3 and Glacier bucket. So this introduction is all about that. And we have also integrated this system with blockchain. We have decided to integrate it with blockchain technology so that the security of the contents we will be storing on Amazon S3 bucket will be increased. So the picture review. And about system architecture, the system architecture comprises two primary components, that is cloud-based storage for video frames using AWS S3 and Glacier bucket, and decentralized logging system using Ethereum bucket. So the basic idea we have came up is uh, we will be storing the frames on our buckets, and then we will be storing logs about the storage, like at what time the frames are being stored on the bucket, who is using, who is logging, who is able to edit and delete and access the contents that are stored on the bucket. That all logs will be stored on Ethereum blockchain, so that every time a user logs in or tries to delete or tries to edit the contents, we will be immediately knowing about it in the Ethereum blockchain through the logs. And these components work together to ensure the secure storage of video data and the transparent logging of user operation. So basic steps are motion detection and processing, then the cloud storage, and then security and access control using the Ethereum blockchain. Uh, I'm sorry about the quality, but I am having some network issues. So the basic steps will be motion detection using OpenCV library. Then we will be storing it in the local storage, that is the AWS S3. And then we will be performing some video compressions and like deleting useless frames which have no motion at all. So we will only be collecting frames which will be having some motion, so that that this is the only step of pre-processing and video compression. And then we will be storing it on the bucket and AWS archive for important data that should be stored for a long time. What happens in the AWS S3 bucket is that it stores data for some for a little period of time, that is for some months. So if we want to store some frames, the video frames, for a longer period, so then we will be storing it on the Glacier bucket. Glacier bucket is basically a type of bucket which stores the archived data or contents. So for long time storage, we will be using Glacier bucket, and for short time storage, we will be using AWS S3 bucket. And then comes the blockchain part, that is user authentication and authorization, and who will be using the buckets and the contents, and that will be stored on the cloud. This is about the architecture. And now the blockchain logging for transparency, CCTV, the same thing I explained earlier. The CCTV camera pre-processing, motion detection, compression will be done. Local storage will be done. Cloud storage, the storage part will be done on the buckets. Long-term storage will be done on the AWS Glacier. Then data encryption and security will be provided by the AWS KMS and then we will decide the user will we say that authorizer will decide who can view and access those contents, and such that if access is verified, log and operations will be stored, and such that our data will be stored on the Glacier buckets. And now integration of AWS and Ethereum for secure surveillance. I have explained it a little bit here. That is, the linking of AWS and Ethereum is crucial to guarantee that the system is not only efficient but also safe. And AWS Lambda functions connect AWS system and the Ethereum. Using it, the system is able to log operation in real time and without much latency. And the comparative results are the proposed system was reviewed and developed using AWS S3 to store the video frames at 5 to 10 frames per second, and other previous video data was stored in AWS Glacier. Motion detection by OpenCV was done before the actual frames were stored. This means that instead of storing all the video frames, only frames with motion was stored to save on space and storing more video frames. These frames then pass through some pre-processing steps that includes video compression and the size of the frames to fit the frame to the current size required for easy transfer and storage. Other milestone of our project idea, research paper title, also deserves some recognition in integration with the Ethereum blockchain. This in a way made certain that all operations that might be done on the stored video frames, that is upload, deletion, and modification, were easily logged. Each operation that was performed by the bot was recorded in the blockchain, therefore creating another layer of assurance that three malicious activities were conducted. Comparative results. Safety was an important component of the solution, and S3 object lock and MFA delete were used to help secure the bucket from being deleted by applying some restrictions that could not be overridden. All video frames were also encrypted by AWS using KMS both for storage and transmission. This also made it possible that even if someone got into the storage unauthorized, so the video data could not be read, or better still could only be read using
Dear
the encryption
presenter,
key.
you have 2 minutes left.
Yes, ma'am. So this is about the research paper. And this paper presents an architecture for the deployment of CCTV surveillance along with AWS cloud services and Ethereum for the recorded video operation logging. To limit the amount of data in the subsequent steps, motion detection was applied to the frames together with initial pre-processing by OpenCV. AWS S3 and Glacier and Ethereum effectively represent the core solution components since AWS S3 and Glacier are scalable and extremely secure while Ethereum conveys tamper evidence. Applying AWS secure storage and encryption with blockchain's immutable logging proves that the system meets data integrity, security, and tamper-proofing challenges in the modern CCTV surveillance system properly. So these are the references. Thank you.
Thank you. Any questions, ma'am?
If we talk about the scalability, then how your proposed system be scalable for the urban-wide CCTV networks?
Ma'am, in today's time, many organizations use Amazon storage only, AWS storage only. So we have first researched upon that only, that will it be useful for bigger organizations, or we can say in colleges, universities, CCTV are used on daily basis. So, and there were also case of Kolkata where a girl was raped and all the evidences were erased. So we took inspiration upon that. Using blockchain, the evidences will not be erased. Everything will be locked. And since AWS is there, every organization and universities can use that at a lower cost and store the frames that will work as an evidence for everything that will be happening.
Okay, thank you.
Thank you, Saloni. Thank you. So we have our next presenter with us, Shailaja B. Jadhav, who would be presenting a paper on adaptive ensemble classifier for data stream analysis, flight stream data. Yes, ma'am. Are you ready?
Yeah. Hope I'm audible to all of you.
Yes, yes. You can share your screen, please.
Yeah. Thank you. Good afternoon, all of you. I am here to present the data stream classification using adaptive ensemble classifier. Just to tell you what the topic is, we are dealing with increasing data-savvy applications, inspiring data scientists to devise more sophisticated ways of modeling real-time data, which is highly dynamic and extremely speedy. So existing approaches are there which are able to adapt the concept learning to some extent. They are adapting dynamism as well. But very few of them, they are considering the real-time data and they are able to extract the online on-the-fly meaning of the data or knowledge travel. So they are also unable to keep the live data of applications. So this is necessitating a streaming data analysis system, which is an emerging area of research. So we are here to devise a method of streaming data classification. Particularly, we are dealing with flight stream data, which is presenting a comprehensive design framework of a multi-layered ensemble built through a frequential analysis and which is using the pool of the classifiers. So the model is experimented with known platforms of streaming data analysis, such as Scikit Multiflow and massive online analysis. So just to give the idea of the research, this was the abstract. And then the introduction of the topic is what do you mean by the real-time stream data? We are dealing with data sets and the data, different data structures. But real-time stream data has no specific origin or no specific end. It is a continuous unlimited inflow of observations. And these data flows, they are characterized by, they are having high volatility, they have enormous volume, and the characteristics are unpredictable. So differentiating their typical normal behavior from the normal data. So in most cases, it is not always possible to store all the historical examples or the samples. And we have to devise a method which is extracting the knowledge from the on-the-fly data or on-the-go data as it is. So real-time knowledge over a subset of the samples. It is a recent percentage of all observations. And therefore, we have to model the approximation system as reliable as you can. So this is using some architectures of big data systems. They are generated by industrial IT automation systems and they are coupled with real-time processing requirements. We have the architectures of data processing algorithms, PRAL. So these are real-time data stream processing algorithms, which are capable of dynamically adjusting as the new prototypes. So coming to the research approach of our paper, this research work is concentrating on a multi-tiered ensemble learning, which is dynamic in nature. And instead of using the traditional cross-validation technique or a holdout data set, we are here using a new technique known as frequential evaluation, which is a major contribution and which is distinguishing our work from the earlier works. And this is because the traditional methods of machine learning, they are built upon the holdout set, which is keeping some data as trend data and the other data as test data. So here, as we are dealing with real-time data, we don't have this easiness to divide the train and test as different sets. So we have to take 100% data to train the model and which is able to give the approximation error as less as possible. So just to give you the idea of what is learning from data streams. So here you are seeing that stream is having a continuous inflow of observations where some level data is used to train the model. Model gets updated. And once you have the ready model, which are taking the next sample or the unlabeled data, and you are going to predict that. So here, the holdout and frequential, these two are the different approaches. We are dealing with frequential since every time the stream is used to first test the model, and based on this test analysis, we are doing the updation of the model and the classification error updation. So both these parallel works, they are being done, and at the end, we are going to approximate the error as an average error, which is too low as compared to the traditional holdout set. On the right-hand side, you are seeing the pseudocode for the frequential evaluation, which is known as the predictive sequential, or it is in some cases known as test then trend. So for every sample, the model is being tested and 100% data is used for training and testing the model. which is the very crucial point of this analysis, particularly used for streaming data. Now, as we're dealing with multi-tied ensemble, just some details of design of the ensemble. We have the data coming in the form of the stream, and it is gone through first level 1, level 2, and level 3, because we are having 3-tier ensemble. So the first layer deals with the incoming data stream, and the predictions of that layer will go to the next layer, and the third layer acts as a meta model. So we have designed a system which is a stacking based ensemble, wherein the classifiers, they are of the type Gaussian naive Bayes. We have a stochastic gradient descent, we have random forest, and we have the variations of Herefording tree. So we have kept some benchmarks for the selection criteria for the classifiers, because we are selecting the classifiers based on their performance. So for the layer 1, we will be dealing with the selection criteria as mean precision and mean time, because time is very crucial as we are dealing with real-time data streams. So time is the most crucial part. So we are going to achieve a best midpoint or a golden midpoint for the classifiers, which are giving acceptable level of precision in the very meantime. And for the last layer, that is a meta classifier, we have kept the selection criteria as higher precision and a very quick response. So the frequential evaluation comes in this phase of the architecture. The continuous data flow undergoes the frequential evaluation learning strategy, where all the classifiers, all the constituent classifiers will be given, and we are adapting those classifiers based on the selection criteria of their performance, wherein we are checking whether every classifier is able to deal with the concept drift or the dynamism of the data. And according to that, we are tuning the hyperparameters of those classifiers. So only the classifiers which are performing well in this criteria, they are added to the classifier pool. And then those classifiers will be coming in the architecture of our model, where tier 1 classifier pool is kept ready, and tier 2 classifier, that is layer 2 classifier, is also kept ready with this data. So all these classifiers, they are already learned with the concepts of the real time, and they are able to predict at any time. So once these classifiers, they receive the stream data, stream instances, tier 1 gives the predictions. So tier 2 has the earlier layers predictions as well as the original features. So it had some baseline how to predict and what to predict. So combining these 2 layers predictions, they will be the meta classifier, and that meta classifier gives a final classification for this real-time data stream. Our design policy is based on some surveys of the literature, wherein we are using a sliding window, almost of 1,000 instances at the same time, and a number of classifiers in each layer, that we are dealing with the experimental analysis and a trial and error approach. So using this, either one can deal with sliding windows, or one can go for the fading factor. So fading factors, they are memoryless. So both these are the important steps for the streaming application. Then these are the intermediate results, wherein we have tested all these classifiers for their position in the layer 1 and layer 2, as well as for layer 3. So here from these results, it is clear that Herefording tree classifiers or some random forests, they are giving the better performance in terms of precision, as well as their time required for training and time required for testing. So all these classifiers which are fitting in our criteria, they will be taken for the tier 1 and tier 2 of the ensemble. Just the right-hand side of the slide shows the experimental setup, where we have used in some cases CPU and GPUs as well, because the data was voluminous enough, and the scikit-learn laboratory along with the scikit multi-flow framework for APIs of real-time classification. Some advancements in machine learning classification we have dealt with in scikit multi-flow. Then these are the final results for the performance analysis of our embedded CSA model, wherein we have tested the 2 airline data sets, airline on-time performance data and BOT US data, where we have kept the evaluation matrices as mean accuracy, mean time taken, and our model has is compared with the three known ensembles, that is dynamic weighted majority, accuracy weighted ensemble, and accuracy enhanced ensemble.
Dear presenter, you have 2 minutes.
Yeah, sure, ma'am. I will be able to finish. And this model has given the very good performance in terms of accuracy as well as the mean time taken for both the data sets. Our work is continuously going on, wherein we are again testing our data for the other real-time data streams as well. And the same strategy of learning the evaluators using frequency evaluation that we are keeping. This is the graph for the observations and performance. So here the main challenge was to find out the trade-off between cost efficiency and the performance, as the classification and the machine learning, it demands for the very good computational powers and the performance. So our model is using active online learning. So this is a very good point when we have to find out a golden midpoint between the cost and the performance. Then again, a frequency evaluation saves time and it approximates the final error, average error across the model. And there is no need to train the classifier every time when it has the new instance in front of it, because we are keeping the learned already classifiers in a classifier pool. So these are the three distinguishing points of our model. Some potential limitations we have found out from the work is there is still a very lack of benchmarks to assess the adaptive classifiers. The primary issue is there is potential for data bias, as we are dealing with stream algorithms. And this is a very expensive task since it is to be done continuously. So traditional data processing algorithms, they are not at all suitable for this work. And this demands for some sophisticated speedy computational environment as GPUs. And one more issue is we have to handle the latency and delayed information as well. These two are always there. So to conclude, the work is there is still a scarcity of established benchmarks and frameworks. Some feature engineering part for the streaming data, it plays a very vital role in order to reduce the dimensions and in order to reduce the time required. So frequential has played a very good role. It improves the results of streaming analysis. And one can go for the extension of this work as this can be applicable for multiple domains for multi-class classification, and using some human knowledge or domain knowledge in conjunction with the human interventions, it will be a very good extension for this work. So these are the references that we have referred. And thank you for the viewers and the audience.
Thank you. Thank you, ma'am. Any questions?
Yes.
Yeah.
Are there any notable trade-off between accuracy and the computational efficiency in your model?
Yeah, actually, in order to deal with streaming data, machine learning models, they give a satisfactory performance, but at the cost of the time taken. So if you have to take the two ends, that is time and accuracy, it is a very challenging part for our streaming data calculations. It is a very big challenge in front of us.
Okay, thank you.
Yeah, thank you.
Thank you. Okay. Do we have the presenter of the paper titled EduShift AI-driven web-based application for personalized learning here? Any presenter of this paper, please?
Yes, ma'am.
Please share your screen.
Okay, ma'am. Good afternoon, everyone. I'm Sayanikta Sudrgundla, and I'm here to present our project paper titled EduShift, an AI-driven web-based application for generating the personalized learning. And this is a platform where users can get the content according to their preferences. And coming to my abstract, Actually, we had identified a problem that nowadays, so if suppose a user want to search for a certain content like any topic or any other questions, and they need to search for several websites. In some websites, they will they will often go to the Google and search for a content, but it will provide so many websites, and the users have to go to every website and check, and some people even won't get the correct information and according to the level of understanding and the required format they want. So what we thought of building an application, web application, where we can provide user with the level of understanding, means we'll ask the user for uh, to enter the whatever the level they want, means like low level content they want or medium level or else high level content, and also the format they need to the format they can easily understand. And by asking these inputs from the user, and we will our model will generate the text or audio or video so that the user can be understand. And this is our abstract. And coming to introduction, we had actually found some existing solutions, like they will provide the content as per the questions that has been asked by the user, but they won't specify for like if suppose the user wants to the user wants to low level content or else medium level content or high level content, they won't specifically these websites will give that particular level of content. And here in this project we will mention that clearly that and it here in this project we will also able to give the content in three formats like text, audio, and video based on the user's chosen format. And this is our proposal framework of this project was a web-based application. And key active contributors for this is we had chosen some models like GPT 3.5 Turbo and GPT 4, and these we had done a comparative analysis for how far they are correctly generating the text as well. And then we after generating the text, and we will convert the text into the user preferred format like in a text or audio or video. And for converting into audio, we had used GTTS, and for converting into video, we had used Ramos text to video synthesis model. And we had also searched like similar related works. We had seen that they had some papers like converting from text to audio or else some instructions based on the instructions giving audios. And so we thought of creating this application which will be easily benefitable for the students. They are in a learning stage, so that they can easily come to one platform and search for the content relevant to them and specify their responses, their preferences, and easily get the content efficiently. And our proposed methodology will like you initially the user will be come to our website and enter a particular topic or question, and then they will choose the format like audio, text, or video, and choosing their understanding level, that is low level or intermediate or advanced. Then our LLM model will generate inputs like based on the question and the format and the understanding level mentioned by the user. It will first converts the generates some content, and then further converts into a format mentioned by the user, and then will be presented it to the user. And actually the voice text to voice generation will be done like this, like the input text will be generated by the model, and then it will be the tokens in the in that particular text will be divided, and then it will check the parts of speech, and then syntax phrasing will be checking text analysis, and then language modeling will be done, and then from that the speech will be created and will be displayed for the users. If the user preferred like I want to know the topic like trigonometry, and I want to learn it in a audio format, and level will be medium, then it will give an audio file with the content related to trigonometry in audio file. And our framework components are mainly for text generation. We had just compared models like GPT 3.5, Turbo, and LLM MA models. And then we had uh, used ASL, CC, and Q for the comparison. And then we will provide a personalized content for the users with an optimized formats like text, audio, and as well as video. And our results will have checked that how these models will different from the other some other models, like means how they are giving descriptive. This is a statistical analysis for semantic fluency responses, means how well they are responding for the if a query has been asked to them. This is mean by group result. And we are also giving how unique type of responses all these models are giving, and we had checked that. And we have done a comparative analysis for all these models by using by comparing ASPL clustering and modularity. ASPL is nothing but average shortest path length, and clustering coefficient is how much nearer they are, and modularity, which evaluates how well topics are
Dear
segmented into
presenter, you have 2 minutes left.
okay, ma'am. Meaningful subgroups. And in conclusion, we had achieved in creating the content in a formats like audio and text as well. And we are dealing with video, which we need a GPU. And and a future work is to generate more human-like content so that it will be easily understand by the user. And these are our references we had seen. And thank you. Any questions?
Thank you, Nikita. Any questions, ma'am?
Yes. How sorry. How does this application, that is EduShift, will measure and adapt to the learner's process over the time?
Actually, in a learner stage, every student or anybody will be wanted to learn. Means they wanted to learn some topics, ma'am. But they will even go waste the time in searching of so many websites or else so many platforms, and they may, even though those websites may contain the relevant content to them, but they may or may not be understand by them, ma'am. So actually, what we thought of is giving a content that can be easily by preferring the level, like low level or medium level or high level. So as the user first enters the level of their understanding and the format. So and they will also give the topic they want to learn, and the model will be generated the text, audio, or video as per they mention, so that it will be easily in one platform that user can easily get the content, ma'am. So no need to
No.
search for multiple websites.
Okay, okay. Thank you.
Thank you.
Thank you, Nikita. Thank you, ma'am. So we have our next presenter with us, Penumala Samya, who will be presenting a paper on enhanced dental cavity detection using Riemannian residual networks and improved Sooty turn optimization.
Yes, ma'am.
Yes, please. Share your screen, please.
My screen is visible, ma'am.
Yeah, but I cannot see.
Hello, ma'am.
Yes, it's visible now.
Good
Start,
afternoon,
please.
everyone. I'm Samia. I'm here to present my work. Ma'am,
Yeah. Start, please.
can I start?
Yes,
Good
please.
afternoon, everyone. I'm Samia. I'm here to present enhanced dental cavity detection using Riemannian residual neural networks and improved Sooty-turn optimization. Well, this work will present as like when where was the cavity's presence as like we have premolars, molars, and incisors. Where was the
Your
cavity
slides are
present?
not moving. Yeah.
Coming to the abstract, we have a problem statement was like traditional dental cavity systems have low accuracy and high error rates. We are here to reduce the error rates and accuracy by using Riemannian residual neural networks optimized with improved Suggestion optimization algorithm, ma'am. We have been using guided box filtering for noise reduction and improve image enhancement. By using guided box filtering, we are being considering the another image, and that image is being filtered, and the image context will be compared to the another image we are going uh, uh, to the model. Feature extraction, we have been using inception with transformer for effective pattern recognition. We have been achieved results of 99% accuracy and 99% recall using the Dentex dataset. We have collected the dataset from the dental college ahead of our college. Impact enhanced diagnostic precision and reduced false positives. Coming to the introduction, we have been came up with the problem statement, like dental cavities affect 60 to 90% of children, nearly all adults globally, causing pain and tooth loss if untreated. uh, early detection of cavities is late being during these days. We have been identified that some of the uh, cavities are not being recognized early, that leads to pain and tooth loss. We have been proposed a solution and advanced framework integrating residual neural networks and optimized with improved Suggestion optimization algorithm for accurate and effective cavity detection. Coming to the key contributions, we have used guided box filtering for improved image quality, inception with transformer for robust features extraction, residual neural network optimized by improved Suggestion optimization algorithm for efficient classification. Coming to the dataset, we have collected the dataset from college. Performance, we have been superior accuracy and recall compared to the existing methods. Related works that is being done according to our project, that was we have paper and the model or method that was used by them, and key findings and the limitations by the paper that has been done already. The limitations was tested only on peripheral X-ray images. Performance on complex structures is unclear. Needed high quality X-rays. Lacked deep learning and modern comparisons. No predictive modeling. Limited to panoramic X-rays. Less accurate than deep learning. More. Coming to the proposed methodology, we have been here with image acquisition. Using images are being processed using guided box filtering, feature extraction using inception with transformer, classification by using residual neural networks being optimized by improved Suggestion optimization algorithm. Coming to the flowchart, we are going to give an input image that is being pre-processed by using guided box filtering. Guided box filtering is nothing but when an image is being pre-processed, that image has some data. The data is being stored, and the data is being compared with the another image that is going to be an input image that is going to filtering pre-process the data that is needed to be used. Coming to the model net v2 network, that is the model we are going to use for the technology that is being to used for feature extraction. Other than that, the next we are going to use Riemannian residual neural networks for classification. We are going to classify classes as we know that we have premolars, canines, and incisors. We specifically know that where the tooth decay is located. Is there located in premolars, canines, or incisors? Where it was located, we are going to classify that. We are going to have some performance metrics that is going to be then the accuracy is up to the mark. Then we are going to improve by using Suggestion optimization algorithm. By step-by-step approach, we are going to initiate the model, then initiate the parameters of the improved Suggestion optimization algorithm for the residual neural networks weighted parameters. We are going to process where like image is being inputted. In input image is going to of dental image, then guided box filtering is going to happen. Then the hidden layers are going to be there. Hidden layers, every hidden layer we are going to use an softmax activation function. Every activation function has its own output. Then output is going to compare with all the layers. Then all the layers is going to have some process function. Then it is going to criteria. Based on that we are going to threshold function. Then the function is going to show the error rate and computational complexity are reduced or not. Then we are going to terminate the process. Dataset description. Dentex dataset contains a panoramic X-ray images with detailed annotations for dental conditions, supports segmentation, detection, and classification tasks. Key features: tooth level labeling for incisors, canines, and premolars. Results: we have been achieved accuracy of 98%, precision of 98%, recall of 98%. Comparison with existing models, traditional models achieve 85 to 87 accuracy.
Dear presenter,
Our
we have 2 minutes left.
Yes, ma'am. Proposed methodology, we have the proposed methodology we achieved 98% accuracy. Coming to the results, this is the ROC curve. We have been shown that false positive rates are being reduced, true positive rates are being increasing. Convergence over iterations for 10x dataset, where the convergence over iterations are being increased over the period of time. Coming to the results of number of validation loss and accuracy for Dentex dataset is here, that the loss accuracy is going to be increased and the loss is being reduced. Coming comparative analysis, we have compared the models that is being already done, existing models. Coming to the TSAI DCD, that we are going to see that accuracy is 86%. VLMDA, we are seeing that 87%. Our proposed methodology has 98% accuracy. Conclusion: high accuracy and recall with optimized computational efficiency, effective for large clinical datasets, future work, enhance real-time detection capabilities, explore integration with transfer learning. Reference: these are the reference we are considered for our work. Thank you.
Thank you.
Any questions, ma'am?
Yes. Okay. What potential improvement could you make in this your approach, which is suitable for clinical deployment?
Yes, ma'am.
Shall I repeat?
We are have. Yes, ma'am.
Okay. Continue.
Like ma'am, we are going to use this application for large clinical information, ma'am. It is going to like potential impact is like we are using X-ray images. Some we know that tooth decay is having some is caused by biting the food that is being not removed from that tooth, that is going to decay by you adding some sweetness or like that, ma'am. The potential impact is like when the image is being processed and multiple times we are going to process the image, then early detection of cavity is being done here, ma'am. We are going to detect the early cavity detection when that biting is happened. We don't know early stage, we don't know we are going to have a tooth decay. We just know that we are going to have some pain in the tooth. Then we don't know that it is going to be we are going to happen at tooth decay. That's why we are going to use detect an early detection, ma'am. That is the potential impact we are going to make, ma'am.
Okay. Thank you.
Thank you, ma'am.
Thank you. Okay, so we have our last presenter with us. Aisha Karigar, who would be presenting a paper on predicting problematic internet use severity, a machine learning approach using physical activity and behavioral data. Aisha, can you hear me?
Yes. Am I audible?
Yes, you're audible. Please share your screen.
Okay. Is the screen visible?
Yeah. You can start from the first slide. Yeah. Sure. Please start.
Okay. Good morning. Imagine a world where internet addiction could be predicted before it becomes a serious problem. Today, I will share how our research leverages machine learning to predict problematic internet use severity using physical activity and behavioral data. With increasing internet usage, especially among adolescents, PIU has been a critical issue affecting mental and physical health. Our study aims to classify individuals into PIU severity levels using machine learning models trained on behavioral and physical activity data. What is PIU? PIU is excessive uncontrolled internet use that impacts academic performance, social interactions, and mental well being. Studies suggest an inverse relationship: less physical activity correlates with higher PIU. We used the Healthy Brain Network, which includes over 3,000 participants aged 5 to 22, integrating accelerometer data, demographic data, and physiological data. These are some of our columns from the data set. Our objective was to develop a predictive model, analyze physical activity data, use wrist-worn accelerometer data to assess how physical habits correlate with problematic internet use, and correlate fitness measures with internet use, investigate the relationship between cardiovascular fitness data and internet addiction severity, and to analyze electronic gadget usage, examine how time spent on electronic gadgets correlates with physical activity to predict problematic internet use. Now, I would like to present some of our EDA. The analysis, as you can see, there's a clear trend where older participants are more likely to exhibit higher levels of PIU, with median ages increasing across SII categories from 9 to 14 years. Here you can observe that physical metrics show a strong correlation with SIA categories as median height increases from 53 inches in category 0, that is the none category, to 64.5 inches in category 3, that is the severe category. And median weight rises from 68.2 pounds to 159.6 pounds, indicating that older, taller, and heavier participants are more likely to have higher levels of problematic internet use. Systolic and diastolic blood pressures increase with higher SIA severity, while heart rate slightly decreases, indicating that elevated SIA levels may be linked to age-related physiological changes or reduced physical activity. Sleep disturbance score revealed that sleep disturbances increase with higher SII categories from a median of 54 in category 0 to 66 in category 3, indicating that greater PIU correlates with more sleep issues. Now I would like to explain our workflow. We came up with multiple ways to do pre-processing. In our base one model, what we did was we did median imputation, and we did KNN imputation for missing data. And in base two, we applied median imputation for numerical data and missing imputation for categorical data. We created features like BMI X age to reduce dimensionality and improve accuracy. And then we used autoencoder to handle time series data. We applied models like LightGBM, XGBoost, CatBoost, and TabNet. We used 5-fold stratified cross validation because this was categorical classification. Then we used quadratic weighted kappa as primary evaluation metric. We used kappa optimizer, adjusted prediction thresholds for better alignment with actual value. Then we customized tuning for each model to improve performance and imbalance data set. This is our methodology. Now I'd like to tell something about our models. We used XGBoost because it is known for handling large data sets and it prevents overfitting with L1 and L2 regularization. We used hyperparameters max depth, controls model complexity to avoid overfitting, and learning rate we set it to 0.05 for balance between speed and accuracy. We achieved consistent performance on majority classes. In CatBoost, we observed that CatBoost efficiently handles category data and performs well on imbalance tuned to category capture complex patterns without overfitting. We set iterations to 200 for robust learning without overfitting. Best model for predictive minority class. We used light GBM as it is fast and scalable for high dimensional data, especially actigraphy features. We used hyperparameters like learning rate, adjusted it to 0.046 for stability, and improved feature processing efficiency, reducing training time by 25%. And finally, we used a neural network model, which is TabNet, because it has its attention mechanism highlights important features dynamically. We adjusted learning rate to 0.05 for stability, and we adjusted max depth to 12 to avoid overfitting. This provided insights into critical predictors, but had lower accuracy on imbalanced data. This was a result. As you can observe, CatBoost performed the best. Public score and internal score is evaluated using quadratic weighted kappa. Our conclusion is that our study explored SIA levels of POI using diverse data sources, and CatBoost performed the best, while XGBoost and Light GBM showed strength in majority class predictions. Tabnet offered interpretability but lacked in predictive accuracy. Quick highlighted the importance of nuanced predictions, not just accuracy. The research emphasized the role of feature engineering, particularly in handling high-dimensional data, actigraphy data, and creating interaction terms. Future studies could improve through additional feature engineering, temporal data integration, and enhanced balancing techniques for moderate and severe categories. Overall, the findings contribute to understanding and mitigating PIU, suggesting avenues for future refinement and potential public health interventions. Thank you.
Thank you, Aisha. Thank you. Any questions, ma'am?
Yes. What specific challenges is obtaining or processing the data for machine learning you are facing? Now, in our data, as you can observe, we've taken physical data. Sometimes the data can be dirty, like heart rate is not actual heart rate. So we had to perform pre-processing in a way that we are not only taking care of data that is missing, but also data that has error. Like unit errors, and in weight there is unrealistic data, like somebody set weight as 0, which is technically null. So we also took care of that. And because our data set was imbalanced, we explored a lot of techniques like random oversampling. Ultimately we took SMARTCOM because it uses k nearest neighbors. So it takes care of similar users, and on the basis of that it upsamples the data. Okay, thank you. Yeah,
Thank you,
okay.
Aisha. Thank you.
Thank you.
So we have come to the end of this session. I sincerely thank our authors for this excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. I, on behalf of the whole team, thank you for the support during this 9th version of the conference and all the previous 8 versions as well. We will be happy to see you in the 10th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days, and the publication will be live within 6 months, and the papers have been forwarded to the Springer board as well. So kindly cooperate with the team of SMARTCOM. I also thank our session chair. Thank you for chairing the session, ma'am. This is a token of appreciation from our side. It was great to have you here. Thank you, ma'am. Thank you so much. Thank you, ma'am. It was great to have you here. I hope all the participants also enjoyed the session. Thank you so much. I request all the participants to turn on their cameras for a quick snapshot, please. All right. Thank you. Thank you so much, everyone. Take care. Stay safe. Bye-bye.